In this particular video, we are going to learn about reliability assessment of a tool with binary responses or dichotomous responses, which we mostly find in our knowledge questionnaires, where you can ask a respondent whether to choose an option yes or no, or true or false. So in the course of your research, maybe you have submitted it for a review. They might request that what is the internal consistency or reliability of the tool you have used. So, and you need not to panic. The most common one used is the Kuder Richardson test, often known as the Kuder Richardson Formula 20 or KR20. So the first part of this video, we are going to learn about it, after which we follow with procedures on how to perform this. So the Kuder Richardson test is a statistical test or method used to measure the internal consistency and reliability of a test or assessment with binary or dichotomous items. So questions scored as correct, incorrect, yes, no, true, false. It means that they have only two response options. It means that you can use this test. So what are the key features? The purpose is to determine the reliability of a test in terms of how well the items measure the same underlying construct. Applicability is used when items or test items are dichotomous, that is, they are being coded as 0 for no or incorrect and 1 for correct. So it's suitable for educational tests, questionnaires, and assessments. So the formula is this. As you can see, KR20 is equal to K minus divided by K minus 1, bracket open, and the rest. So since this is not of interest for us to do, so we only need to skip this. But this is just a formula as to how to calculate it. So it is the statisticians who can do this. So the interpretation is just like the Cronbach alpha. It also ranges from 0 to 1. And the higher the value, the higher the reliability. So, and it also uses the cutoff or the minimum or recommended cutoff, which is 0.7. So if you calculate it and you have your items 0.7 and above, it means that the tool is valid and you can continue with your study. However, if it is below that, it means that you need to delete other indicators. And when you delete the indicators and you still find your value still not exceeding 0.7, it means that you need to restructure your question, or you need to bring in a new tool on that particular aspect you are trying to measure. So it's very important to do the pilot testing before you do all this, or else you might finish with your study and you calculate and you have 0.4. It means that your tool is not valid. So what are the assumptions? All items assess the same construct. It means that if it's a knowledge questionnaire, all items should be knowledge question. We shouldn't go and see attitude or perceived behavioral control or maybe any skill. So is skill and is, but you should note that it's not necessarily a skill, but it's only how do I even say it? Items. When we say items, it means that they are in statement forms. Cancer is a dangerous disease. Cancer is a progressive disease. Cancer affects majority of women. So you see, these are statements, and you have provided options like yes, no, correct, incorrect, agree, disagree, true, false. So that means that they all measure the same construct. Test items have dichotomous responses. So it means that just like the options I gave, they should be dichotomous. It means that they should be two. Items are independent of one another. It means that when an item is there, you shouldn't have another item of the same meaning. So let's say, for instance, cancer is a dangerous disease. You can't have another item like cancer is a dangerous disease again, and you can also have something like cancer is a bad disease. They need to measure different things, so they have to be independent of each other. So this test is particularly for dichotomous data, whilst Cronbach's alpha is more general and can handle continuous or like scale data. But you should know that in the performing of the Kuder Richardson, you will see a tool that is actually measuring this type of reliability. We are using the Chromback Alpha interface or menu using the same Chromback Alpha estimates, and any value we get with the dichotomous uh, tool or data we have is the Kuder Richardson value. So what we need to do is to look at this. So this video we are going to use SPSS. So I have my item here, measuring knowledge on farmer planning, and respondents were asked based on 16 items to rate their response, either yes or no. Yours can be correct, incorrect, true, false, agree, disagree. So we have it here. So what I need to do first is to check to ensure that the measure is a scale. So you see it's scale. So I have to change it to scale if it is ordinal or nominal. But you should also check to see to ensure that if you are having the correct or the response names, you change them to 0, 1. So any wrong or incorrect response is 0, whilst the correct response is 1. So let's say I have given them yes, no. It means that the responses, if I'm going to code them, it will be 0 for no, 1 for yes. Same way for correct is 1, incorrect is 0, agree is 1, disagree is 0. So that depends on the type of tool you have given to your respondents, or you are giving to your respondents to provide their response. And you should also know that when I mention of pilot test, it doesn't mean that when you just structure your tool, you just input. No, you have to collect data. It works with data. So with this, it's a final study that was being done, and the total responses were 234. And with the 234, we had missing values. So we just go ahead with the test. So we only need to do this. We click on Analyze, go to Dimension Reduction. No, we go to Scale. You see Reliability Analysis. Just click on it. Highlight all your items and populate it in this box, or you populate the box with these items. So we are going to have something like this. You highlight all, then you click here. Statistics, scale if deleted, but this is not necessary, but you might need it should in case maybe your values are not good. So we can say scale if item deleted, then we'll say continue. So you see here the model is alpha, there's no omega. So the omega is for the composite reliability. So you see alpha. So we just click OK. Then we have our output. So in our output here, you see that the number of excluded cases were 7, and it's 3.0. It's less than 5%. So it wouldn't affect our results that much. Let's look at the Chromback alpha is 0.741. So it means that our tool is valid because it's above 0.7. And since our response options were dichotomous, yes, no, where we have 0 and 1, this value doesn't represent Chromback alpha, but it represents the Kuder Richardson's value or coefficient. So if you are going to report, you can say that your knowledge aspect of your tool or the knowledge aspect of your questionnaire had a good internal consistency with value above 0.7 when it was performed using the Kuder Richardson's formula or KR20's formula. So that is how we perform for the the Kuder Richardson's test. That's the reliability assessment of the dichotomous data. But you should note this. You can ask maybe, what if I have 3 responses: agree, disagree, neutral? I've come across, although I've not seen it in a book, but I've come across people discussing, I think like statisticians, sometimes someone will put in questions and those who are experts will provide responses, where it was suggested that you recode the third variable, which is of no interest, let's say neutral or I don't know, to empty. cells or missing values. So let's say let's apply it in, that will be easy for me in my software here. So let me just use jump. So I'm coming. Where is my data? Okay. So this is my questionnaire. So, and let me do a cross tabulation. Then you see. So you see that we have three response options: yes, no, I don't know here. So someone I thought of, if I have three responses and not two, I know that I don't know means it's neutral. Or let's say in the process of answering the questionnaire, most of them didn't choose yes, no. So I can decide to recode or to add a response category and say I don't know. It means that these people didn't choose yes or no. So it was being suggested that you would exclude this particular column by making that column a missing value. So with my software, it's easy. That's why I don't want to use SPSS for that. So I'll just right click here, do my standardize for all items, then recode. So I'm going to make this 1, this as 0, so 1, this as 0, and here I'm going to leave it empty. So, and I have 497 now missing, so I'll click recode. So let me just change the data type to modeling type, click OK, and you see that we now have what? Missing rows. So let me do missing analysis. We had 497, you see it to be 497. So missing, show only missing, sorry, missing value report. We can decide to do this. Let's say that we want to find a sum. So let me do something again here. Sum to 497. So you see it aligns with the response category we excluded. So this is how it was being suggested. You exclude that particular response option or category, then leave only two levels, most important: correct, incorrect, true, false. So you can have true, false, and I don't know. Or you can have yes, no, I don't know. You can have agree, disagree, neutral. So neutral, I don't know, or don't know, or not at all. You use that as your missing column. So since we have it this way, we can apply the same comeback alpha and we'll still get the estimates for the Kuder Richardson test. So I'll just click here, multivariate, open. These are the items. Click here, then comeback alpha. So you see that we have 0.73, which is still valid. Let's compare it with the one in the SPSS, 0.74. So this is slightly. So now let's try to see whether when we still code those values that were empty as 0, let's say the particular category was supposed to code empty, we want it to be 0, means it has no significance. Let's try to see whether the values too will differ, or maybe we can go on with that. So that depends on the type of research you are doing and what you decide to follow. So this is what we have, 0.737. So let's code them as the missing as 0 to 2 to C. So we'll code them as 0. So you can do that in the software that you are using. So we'll make them this, and you see when we run missing value, you realize that show columns, we don't have any missing values again. So let's run the same analysis again, multivariate, comeback alpha. So item reliability, comeback alpha, and we have 0.77. So you realize that they are all within the same threshold, but this one is somehow high as compared to this. So what I would suggest is that you can do both, and if any of them is above the threshold, you can decide to choose one for your research. That depends on what you want to use. So it doesn't mean that when you have only three response options, you should restrict yourself. You can decide to put the other category that is of no importance to your research or is meaningless. You code it as missing and you can still get good values. So these are two approaches to calculation of the Kuder Richardson coefficient.